welcome back. In this video we'll discuss about analog output scale. Last video we also talked about analog output scale, but we have used linear line equation to unscale the analog output. Suppose we have a actuator and that actuator controlled by a pressure, and that pressure also controlled by analog output, analog signal 4 to 20 milliamps. Here we can see that a picture Siemens farid controller, I2P controller. That input is current I and output is P, pressure. Here input analog signal is 4 to 20 milliamps and output will be the range of your pressure input. If the pressure input is 5 bar, then output will be 0 to 5 bar, and that 0 to 5 bar will control the actuator. And to control the actuator, this I2P converter, we need a analog output signal, and that signal we will take from the analog output. Here our control signal type is 4 to 20 milliamps, and you know that Siemens, we already discussed in analog scale block, analog scale video, that for Siemens use 4 to 20 milliamps against 0 to 27648 value, or any other analog signal like voltage signal. So for 4 milliamps integer value is 0 and 20 milliamps integer value 27648. Here we are using a actuator, I2P converter to control the actuator. So here our input signal input is 0 to 100% from the HMI, and that 0 to 100% will convert from by the program, and that program convert 0 to 100% to 0 to that integer value, and that integer value sent to analog output channel. So physically we will get the 4 to 20 milliamp signal. So our set point, as I told, that our set point is percentage here, and that will done by 3 steps, that we will give the set point from HMI as 0 to 100%, and intermediate stage will convert that 0 to 100% as a integer like this, and that integer value will send to the analog output channel, which will give a analog output control signal 4 to 20 milliamps. So that can do by 3 method. We have already discussed about first method, that is linear line equation, and second is scale x and norm x function, and third is HMI scaling function. Today we will discuss about scale x and norm x function. Here this function we have already used by using linear line equation. Today we will add a new function, that analog scale, analog output scale by using norm x function, norm x and scale x function. We already discussed in analog input scaling that norm x function we can get it from the conversion operation. Norm x function will convert the input value to output value as a real, that is real. Okay, and input can be integer or real. So for now our input is real, and that is from HMI 0 to 100%. So our input is 0.0%, and max value is 100% from the HMI, and here our input is that HMI, SP HMI, that will use Okay, data. Okay, now here we need a intermediate variable that will sp norm x out. Okay, that will real also, that also real. So here we will use data block sp norm x out. So here it will convert 0 to 100% set point as a 0.0 to 1.0 unity value. Then we will use the scalex function. So scalex function will convert that output 0 to 1.0 value to our desired value. So here our desired value minimum is 0 and max value is 27648. We want to convert that output range. How? I will let you show here that our input is input from HMI is 0.0 to 100.0%. Okay, so output we need 4 to 20 milliamps, but Siemens don't know about 4 to 20 milliamps. It only recognize integer value that 0 to 27648 value. So we'll convert 0 to 100% to that integer value, and we will write that integer value to our output channel, which will give a 4 to 20 milliamps. Okay, now we'll use that normax output value here as a input. So that scalex function conversion value will write to analog output channel. Here from the device configuration we already add the analog output channel that we already configured as a current output type, current output range 4 to 20 milliamps, and here we use keep last value. When the CPU is stop or fail and for any reason, then output value will be keep as last value when the CPU was running, last running value. If the milliamps 20 milliamps before the CPU stop, then it will keep as a 20 milliamps. Okay, now here IO tag will use that I2P SP, and that input output QW300 we used for linear line equation, and here we will use that Unscale norm x scale x function, scale x function. Okay, so our address is QW0302. We'll write the integer value to that address, then output will be 4 to 20 milliamps. Here we'll write QW302. Okay, Unscale. Okay, now we'll write now we'll simulate and last day we already programmed the HMI. Okay, now we'll go that page. This is the set point we used to check the Normax scale for unscaling. Here I will go. Okay, it is not showing as online monitoring because we didn't call that analog output scale function to our main OB. So I will open main OB, and in last day I have called that function here. So now I will call Normax and scalex function in main OB. Again download. Okay, now go back. This one. Here I will monitor again. See, it's now green. It's monitoring. Now we'll give the set point from. We'll give the set point from HMI. Here now value is 50%. So here it is 50%. It will convert 0.0 to 1.0. So output is 0.5 as a 50%. Okay. Now input of the scalex function is output of Normax, and now it is 13824. Okay. Now if you give 100%, you can see the value is 27648. Now if you write that value to, it's already writing because we use the output channel address QW302 and it is written 27648 integer value. So output will be 20 milliamps. When you measure by meter, we will get the 20 milliamps. If you give from HMI it as a 0, it will be 0. Now output will be 4 milliamps. Okay, thank you. In next video we'll show you how to scale the analog output by using HMI, not using the program in PLC. We need only HMI programming. Thank you.